All right, ladies and gentlemen, this is our last study guide for this school year, Unit 10. Now, I'm going to show using the table and the calculator. So if you decided you like the table better, then stick with the table. If you decided you like the calculator better, stick with the calculator. So I'll be showing both. All right, here we go. So show work for each problem. Draw and shade the normal curve for each. Answer each question completely. Number 1. For a given population of high school basketball teams in Minnesota, the average number of points scored in a game is 68, with a standard deviation of 7 points. So, if your team always scores in the top 25%, that means you usually score blank or more points. Okay, this is a go backwards problem. All right, so the first thing we need to do is draw our normal curve. And it says top 25%. So I'm just going to estimate, and I'm going to say that this is about 25%, and the decimal for that is 0.25. Remember, always change percents to decimals. Now, when we're using the table or using the calculator, remember we cannot use what's to the right. We have to use what's to the left. So if this is 0.25, then this is 0.75. All right, I'll show it with the table first. Then I will show it with the calculator. So the first thing we need to do is we need to find what is the z-score for that spot. So with the table first, I go look for the 0.75, which is on the positive side. I get as close to 0.75 as I can get, and it looks like the closest I can get to 0.75 would be this one, 0.7486. So my z-score is 0.67. Okay, that's going to be my z-score, 0.67. If I'm using the calculator, I'm going to use the inverse norm. So I'm going to go second vars, and I'm going to go to number 3, inverse norm. Sorry, my calculator is being a little goofy at the moment. Let's do that again. Second vars, number 3. There we go. So the area to the left is 0.75. Okay, those of you with the new calculator, just leave that a 0 and that a 1. All right, now those of you with the old calculator, all you had to type in was the 0.75. So yours would look like this, and then just hit enter. So again, you see it's 0.67. So our z from the inverse norm of 0.75 is 0.67. Now, we're going to set this up. Remember, our z equals the x minus the mean divided by the standard deviation. All right, so we found the z, which is 0.67. We set it equal to x. That's what we're trying to find. That's the score. Minus the mean, which it says right here is 68, divided by the standard deviation of 7. All right, so when we go backwards, remember my little trick I showed you. You start at the 7, you go around like that. So what you're going to do is you're going to multiply these two together, and then you're going to add, because you're undoing it, you're going to add the 68. All right, and when you do that, you end up with x equals 72.69. Well, you can't have a 0.69 of a point, so we're going to round it up. So we're going to say 73. So if your team always scores in the top 25%, that means you usually score 73 or more points. Okay, letter B. So again, we start with drawing our picture. This says bottom 10%. Well, bottom would be down here. And the decimal for that is 0.10. So first I'm going to go to the table just to show you. So I'm on the negative side. I'm going to get as close to 0.10 as possible. So I look along. Okay, I'm looking here. Looks like 0.10. The closest I'm going to get to 0.10 is right here. And if I go across, that will be negative 1.2. And then I go up and I get 8. So my z is negative 1.28 by using the table. Okay, on the calculator, again, I'm going to use the inverse norm. Okay, but this time I'm looking at 10% because that's what's to the left. And I get the same thing, negative 1.28. So my z equals the inverse norm of 0.10, which is negative 1.28. Okay, I set up, I've got all my information, so I'm going to plug my numbers in. So I have my z equals x minus, the mean again is 68, and the standard deviation is 7. So I'm going to go ahead and undo that. I'm going to multiply and add. And when I do that, I get x equals 59.04. So if your team always scores in the bottom 10%, that means you usually score 59 or less points. All right, let's do another one. The average ACT score over the last 5 years in Minnesota is 21, with a standard deviation of almost 5. This is another go backwards problem. Remember, you have to use inverse norm. All right, so if you score better than 85% of the students, what is your ACT score? All right, so let's visualize that with the picture. Okay, so you scored better than 85%. Well, that's most of it. So I'm gonna go over here. I'm gonna look for this z-score right there. Okay, so 85% or 0.85, that's most of the graph. You scored better than, so you're on this side. Okay, better than will be on the right side. So back to the table first. So I'm going to find my z-score with the table. So I'm going to go to my table. I'm going to go to the positive side. I'm going to get as close to 0.85 as I can. Okay, well, here's 0.8485, and here's 0.8508. So it looks like here the z-score would be 1.04. All right, so now the calculator. So I'm going to put in, again, what's to the left. 0.85 is to the left. we should get the same thing, 1.04. So z equals the inverse norm, 0.85, we get 1.04. All right, plug your numbers in. So 1.04 is going to equal x minus the mean, which is a 21, divided by the standard deviation. All right, we're going to go ahead and undo that. So we're going to take and we're going to multiply the 5 and the 1.4, 0.4. And add 21. So we end up with x equals 26.2. Well, we're just going to round that to 26. So you got an ACT score of 26 or better, okay? But that's the cutoff for 26, okay, for that z-score. So your score should be about a 26. All right, the next one. If you're in the top 5%, okay, well, you're going to have a pretty good ACT score. So that the top 5% or the decimal 0.05. Now that's to the right. But remember, the calculator and the table only give it to the left. So we're going to have to use the 0.95. So we're going to be on the positive side of the table again. So I'm going to go to my table and I'm going to get as close to 0.95 as I can get. Let's see, I've got two of them. I've got this one, 0.9495, and I've got 0.9505. So it's not going to matter which one I use. I'm going to use the 0.9505. So I've got 1.65. All right, so there's the table. Now I'm going to do it on the calculator. All right, so again, I'm going to go and do inverse norm. I'm going to do 0.95. So 1.64. All right, set it up. Solve it, and we find out that it's a 29.2. Well, that would be just a 29. So if you're in the top 5% on your ACT score, you got a 29 or better. And you should be guaranteed some scholarships, because that's pretty good. All right, let's keep going. All right, the following set of numbers represents a simple random sample of high school athletes' weights in pounds around the metro. Okay, how much do they weigh? This is their weights. All right, so the first thing we need to do is type all of these numbers into our calculator. Okay, now I have not done that, so I'm going to take a moment and type them in. All right, I'm putting them in list 1. This will take me a minute. If you want to fast forward through this part, you certainly can. All right, hopefully I did not mess up. So the next thing we need to do is we need to find the mean and the standard deviation. So we're going to go stat, calculate number 1. All right, so good, I did not mess up. So now we're going to round it. We're going to leave the decimals off. We're going to round. All right, so the mean, remember that's the first number, that's 158. And the standard deviation, we're going to round the standard deviation to 30. All right. So based on this data, what proportion of the entire Metro athletes weigh more than 135 pounds? So we're going to set up our z-score. So we're going to go z equals, the question is always the x, so 135 minus the mean, all over the 30. Now, again, if you type that in all at once, please make sure you use parentheses. So we get a z-score of negative 0.77. Now, if you're going to, well, first of all, the next thing we should do is draw our picture. Okay, negative 0.77 is on the left. And based on the information, more than means we should shade to the right. Now, if we're going to use the table, okay, remember the table only gives the values to the left. So let me go to the table. I need to be on the negative side, negative 0.77. So negative 0.7 is here. And negative 0.77 is here. So I'm going to go across. And I'm going to come down. And that's going to be my decimal. But remember, that's to the left. So I would have to go 1 minus 0.2206 to get my answer. Okay, so if you're using the table, you've got to remember to subtract. Okay, now I'm going to go use the calculator. So on the calculator, I'm going to use my normal CDF. So second vars, number 2. Okay, so my lower bound is the negative 0.77. My upper bound is the 100. Okay, hit enter and you should get 0.779. We round it, it would be 0.7794. Okay, so let me do this again. So NCDF, negative 0.77 is my lower bound, comma 100 because I shaded it all the way to the right. Okay, and that's approximately 0.7794. So we'll say that's about 78%. So about 78% of the athletes weigh more than 135 pounds. All right, next one. How about weigh less than 180? So we're going to go Z equals 180 minus 158 divided by 30. That's going to give us a z-score of positive 0.73. That's right about here. Now, weigh less. So I'm going to shade to the left. They weigh less. So I'm going to go to my table. I'm going to go to the positive side of my table, and I'm going to go to 0.73. Okay, 0.7 is right here, 3 is right here, so I'm going to go across. I'm going to come down, and 0.7673. And that's what's to the left. Okay, so that's using the table. Okay, on the calculator, I'm going to go normal CDF. Since I shaded to the left, I'm going to go negative 100, comma 0.73. Okay, and 0.7673. And I'm going to round that to approximately 77%. So approximately 77% chance that they weigh less than 180. Okay, the next one, we have two z-scores. All right, so I need to do both of them. So I'm going to do z equals 145 minus 190. Divide by 30. Z equals whoops, hold on, I made a mistake. Okay, it's 145 minus 158 divided by 30. And 190 minus 158 divided by 30. So my two z-scores are negative 0.43 and 1.07. That's a between. Now, if you're using your table, you're going to have to find both of those. Start with the big one first. So I'm going to go to the 1.07. Okay, that's 0.8577, so I'm going to write that down. Then I'm going to look up the other one, the negative 0.43. That's 0.3336. I'm going to subtract that. Okay, and we should get 0.5241. Now, with the calculator, that's your lower bound. This is your upper bound. And you're going to get the exact same answer, which is about, if we round it, 52%. So about 52% of the athletes weigh between 145 and 190. All right, moving on. Okay, this problem, we do exactly the same thing. We're going to type all of these in list 1. Then we're going to do one variable stats. Okay, I am not going to do that this time. So to save a little bit of time, I'm going to skip that and just go right to the answers. All right, so the mean, which again is the mu in this case, is 20. We rounded, it's 20. The standard deviation that we use is 4. Again, round it to 4. All right, next page. Based on this data, what proportion of the junior class scored higher than a 23? All right, so Z equals 23 minus the average, which was 20, and we're going to divide that by 4. So the Z score is 0.75. Draw your picture. Now, it says scores higher, so that means we're shading to the right. Okay, when I look this up on the table, okay, I'm not going to switch back and forth to the table for this one. So if you go look at the table, it's going to give you the area to the left, remember? So it's going to give you, okay, well, let me go to the table because I don't see it right now. So we're going to go to 0.75. All right, 0.75. So it looks like 0.7734. So to the left is 0.7734. So we have to go 1 minus 0.7734, and that's going to give us 0.2266. If I use the calculator, I will type in my lower bound, comma, my upper bound. Okay, and I get the same thing, 0.2266, which is about 23%. So about 23% of the junior class scored more than 23. B, how about scored below 16? Ooh, that would not be good. So the z-score for that one is -1. Below. Okay, if I go look that up on the table, I'm going to get 0.1586, which is going to be the same thing that I get when I use my calculator. My lower bound is -100. And my upper bound is -1. And I'm going to get the same thing, which is about 16%. So about 16% of the junior class scored below a 16. All right. The next one, we have 2 z-scores. Do both of them. Oops, that's a 20, not a 24. So the first z-score is -0.75. The second z-score is a 1. Draw your picture. All right, so you're going to look up both of those. If you're using the table, look up both z-scores. Start with 1. All right, so we look up 1, okay, which gives us just, okay, let me erase because I got some marks there. So 1 is 0.8413. Then I look up -0.75. All right, here's -0.7, and then we go to 5, which is right here. Let me erase again, right here. 0.2266. Subtract them, and I believe we should get .6147. If I use the calculator and CDF, I will get the same thing. which is about 61%. So about 61% of the juniors scored between a 17 and a 24. All right, moving on. The personnel office at a large electronics firm regularly schedules job interviews and maintains records of the interviews. From the past records, they have found that the length of the first interview is normally distributed with a mean of 35 minutes and a standard deviation of 7 minutes. Okay, notice we're using this z-score where there's a little extra to it. We have to divide by the square root of n. So what is the probability that the first interview will last 40 minutes? So when we set this one up, we're going to go z equals 40 minus the 35 divided by 7 divided by the square root of 1, because it's the first interview. So there's only been one interview. So the decimal for that, the z-score is 0.71. Okay, now it says 40 minutes or longer. That's shading to the right. Okay, when I go to the table and look up 0.71, okay, I'm not going to flip back and forth anymore, so if I go to 0.71, I'm going to get 0.7611. I got to go 1 minus that. And that's going to give me 0.2389. Using the calculator, normal CDF, 0.71 comma 100. 0.2389, which is about 24%. So 24% chance that the first interview will last 40 minutes or longer. Okay, next one. This time there are 9 interviews. Okay, the word first shouldn't be in there. So 9 interviews are usually scheduled per day. What is the probability that the average length of time for the 9 interviews will be 40 minutes or longer? So in this one, it's still 40 minus 35 divided by 7, but this time divided by the square root of 9. When you type that in, you should get 2.14. Okay, that's pretty small. Now, again, when I look that up on the table, 2.14, it's going to give me what's to the left. And that would be 0.9838. Then I have to go 1 minus that, which should give us 0.0162, I believe. Calculator, your lower bound, your upper bound, and we should get about the same thing. Now if I round that, that's about 2%. That's not a very good chance that 9 interviews will last 40 minutes or longer. All right, one more page. A new a new muscle relaxant is available. Researchers of the firm developing the relaxant have done studies that indicate that the time lapse between administration of the drug and the beginning effects of the drug is normally distributed with a mean of 38 minutes and a standard deviation of 5. The drug is administered to one patient selected at random. What is the probability that the time it takes to go into effect is 35 minutes or less? All right, so Z equals 35 minus the 38 divided by the standard deviation divided by the square root of 1. Now, truthfully, you would not have to divide by the square root of 1 because the square root of 1 is 1, and dividing by 1 doesn't do anything. So that's going to give us a z-score of negative 0.60. Okay. I am no longer going to go to the table or the calculator. I'm just going to go through it because it's exactly the same stuff as we've done before. So I'm just going to go through the steps, write down the numbers, and give the answer. So the next thing. And it will be shaded to the left because it says or less. The table gives 0.2742. The calculator should give the same thing. Which is about 27%. So there's a 27% chance that one patient selected at random, it will take 35 minutes or less for that relaxant to kick in. Next one, 10 patients. Okay, that is going to change the z-score quite a bit. That's going to change it to a negative 1.9. That's going to give us a 0.0287 from the table. Which is about 3%. Last problem. Fire department response time is the length of time it takes the fire truck to arrive at the scene of the fire, starting from the time the call was given to the truck. Response times for the Castlewood Fire Department follows a mound-shaped and symmetric distribution. The response time has a mean of 8.8 minutes and a standard deviation of 2.1 minutes. If a random sample of 32 response times is taken and the mean response time x is computed, find each of the following. So what is the probability that it will take less than 8 minutes for the fire truck to arrive? Okay, I'm dividing by the square root of 32 because that's how many response times there are. That gives us okay, now less, shade left, and that will be same thing with the calculator. And that'll be about 2%. So there's a 2% chance that the fire truck will get to the scene of the fire in 8 minutes or less. All right, one more. More than 10 minutes. Okay, that's to the right. So again, when I look this up on the table, 3.23 0.9994. One minus that, which will be the same thing if we use the calculator. Again, 3.23 is my minimum bound, comma 100. Okay, and that is approximately 0.06%. Okay, that's good. Okay, it's not a good chance that they will arrive 10 minutes or later because they need to get there quickly. So there's a chance, but it's not a good chance. That means they're getting there before the 10 minutes. So when it's a fire, that's a good thing. Okay, they need to get there quickly. All right, ladies and gentlemen, congratulations. That is the last unit of the year. I hope that was helpful. Good luck. Talk to you later.